Hello, awesome students. This is part 2 of the reassessment day review. So far, we've already covered standard 6C and 7B. Now we're going to take care of standard 7C and also standard 8A in part 2. So standard 7C is properties on a coordinate plane. So for this standard, we need to identify shapes, we need to plot coordinates and identify shapes and also its qualities. We're talking about calculating midpoint and also the distance formula as well. Remember, the notes that are provided for this standard are the ones shown here. So I'm going to use these notes as I solve number 1. So number 1, it says, given the coordinates -2, 1 and 4, 3, let's calculate the distance between those 2 points. So for distance, we're going to use the first formula, which is shown right there. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, while I'm at it, I'm also going to write the formula down for midpoint since it is a separate formula. It says for midpoint, I'll take the average of the x's and I'll take the average of the y's, and that will be my midpoint as shown there. What that'll tell me is the dot that's in the middle of those two, the midpoint. So let's carefully go ahead and use these formulas to solve for both distance and midpoint. The first one is, well, let's just label it. This is x, this is y, this is x, this is y. The only thing I need to do is decide which one is x1 and which one's x2. So I'm going to just say this is x1, y1, x2, y2, which is the second x, the first x, the second y, and the first y. So calculating the distance gives us, subtract the x's, 4 minus -2 squared. And I use parentheses because I do have a negative there. 4 minus -2. You've got to be very careful with that. And then subtract the y's. 3 minus 1. 3 minus 1, all of that squared. So 4 minus -2 is the same as plus 2. So that gives me 6 squared plus 3 minus 1 is 2. 2 squared. 6 squared is 6 times 6, which is 36. 2 squared is 4. So I get that my answer is the square root of 40. The square root of 40 is approximately, what is the square root of 40?
It's approximately 6.3245.
6.32. So that's the distance between those two coordinates. Remember, if you're using a graphing calculator, you can also just find the square root button right there, right above the x squared button. Okay, next up is problem letter B. What's the midpoint of these two coordinates, the same coordinates given to us? So we're going to go ahead and calculate the average of the x's and the average of the y's. So I'm going to add up -2 plus 4, adding the x's. And I'm going to do 1 plus 3, adding the y's. And that's going to give me my answer very quickly. -2 plus 4 is 2. 1 plus 3 is 4. And now I just need to cut those numbers in half. That will give me the midpoint. So the midpoint is 1, 2. Okay, next up is problem number 2. Identify the shape based on the diagram. So the diagram, it looks so far, it doesn't look like a rectangle, but it does look like some things might be parallel. Remember, to be parallel, we have to have what? Parallel, what do you know about parallel and slopes? Right, there's some notes on this as well. Parallel lines means equal slopes, same slopes. So we're looking for the same slope. Do these two have the same slope? Let's see. -2/4. Let's check the second line here. -2/4. Yeah, these are going to be parallel. Okay, next up, let's check the slopes of, and all this time I'll highlight them. Let's see if those two are parallel. Definitely look parallel. Let's just calculate the slopes. Up 2/2. Up 2/2. Those are also going to be parallel. So right now, I know it's not just a quadrilateral. Quadrilateral just means it's a four-sided shape. No, this could be a parallelogram, it could be a rectangle, and it could even be a rhombus. Are they the same length, though? To be a rhombus, it needs to be the same length and also parallel. Are these the same length? -2/4, 2/2? Those are not the same length, so it cannot be a rhombus. Is it a rectangle? To be a rectangle, it needs to also have right angles. Are these right here right angles? This time I'm going to highlight that. Are these angles going to be right angles? Remember, to be a right angle, it needs to be called perpendicular. And what do we know about perpendicular slopes? Perpendicular slopes need to be opposite reciprocals, just like this. So if these were to be perpendicular, we need to have opposite reciprocal slopes. Now, is 2/2 an opposite reciprocal to -2/4? No. These are not opposite reciprocals, so these angles are not perpendicular. That means it cannot be a rectangle, and therefore our only answer is that it's a parallelogram. Remember, parallelogram just means that they have two sets of parallel sides, which we can confirm is true. So although it could have, for a moment, it could have maybe been a rhombus or perhaps a rectangle, in the end it was not a rhombus or rectangle, it was a parallelogram. Okay, moving on to number 3. It says in the coordinate plane below, plot and connect the points F, I, R, and E, fire, to form a quadrilateral, fire. Mr. Johnson thinks that this shape is a kite, meaning that the adjacent sides have equal length. Remember, adjacent just means the sides that are next to each other. Verify Mr. Johnson's work by finding the length of each side. So for this one, I'm going to go ahead and plot these points. Since everything here is positive, I'm just going to go ahead and create a XY coordinate plane with everything being positive. We have 1, 3. That's F. We have 3, 5. That's I. We have 7, 3. 1, 2, 3, 4, 5, 6, 7, 3. That is R. And we also have 3, 1, which is E. So connecting the dots, we're going to get this shape right here. So at this point, you would need to calculate some slopes. You would also need to calculate some lengths or distance. So I'm going to go ahead and say that you can do this by either using the Pythagorean theorem, or you can use the distance formula. Once you confirm that the distances are the same, which I will say Fi and Re are the same, and once you confirm IR and ER are the same, using the distance formula or the Pythagorean theorem, then you can go ahead and say yes, it is a kite. But remember, in this space right here, you're going to need to use either the Pythagorean theorem or the distance formula for each of those points. Now, you might be wondering, how could I use the Pythagorean theorem instead of the distance formula? Because the distance formula is pretty, it takes a while to do this and it's easy to make mistakes. But what about the Pythagorean theorem? So if you did want to use the Pythagorean theorem, you can just go ahead and create triangles and do 2 squared plus 4 squared equals c squared. I'll complete this first one right here just so you know that the answer is very possible to get. We get 4 plus 16 equals c squared. 4 plus 16 is 20. And if you do the square root of both sides, you'll get that the distance, or c, is equal to the square root of 20. And that is the length of ER. So ER is the square root of 20. You can do the same thing for IR, and you'll notice that it's also a 2 by 4 right triangle, and that gives you that the lengths are the square root of 20, making them the same. Okay, that's it for standard 7C. Let's move on to standard 8A. Okay, standard 8A, identifying exponentials. So for the first one, it's going to be, for the equation y equals 2 to the power of x, state the following. Is it linear or exponential? Exponential. Exponential is in the form y equals ab to the power of x. A is the starting value, while b is the multiplier. Is this growth or decay? It's going to be growth, since it's bigger than 1. What's the starting value? Well, the starting value, this could be written as 1 times 2 to the power of x. So the starting value is going to be equal to 1. Another way to figure this out is if you plug in x equals 0. If you substitute 0 into this equation, you will get your answer for the starting value. 2 to the power of 0.
The answer is 1.
So the starting value is 1. What's the multiplier? The multiplier is 2. What's the value of y when x equals 0? We just calculated that. 2 to the power of 0 is 1. And what is the value of y when x equals negative 3? So we will do y equals 2 to the power of negative 3. Using our calculators, we're going to do 2 to the, that's the button for exponents, 2 to the power of negative 3. And that gives us our answer of 0.125. Or if you did the laws of exponents, this would be 1 over 8. Either of those answers is great. Okay, number 2. Is this linear or exponential? We know that this is exponential. Is it growth or decay? It's growth, since the number here in parentheses, the multiplier, is greater than 1. What's the initial or starting value? The starting value is the number in front, which is 4. The multiplier is 7, the number in parentheses there. And what is the value of y when x equals 4? So we'll need to do 4 times 7 to the 4th power. 4 times 7 to the 4th power is 9604. And now what is the value of y when x equals 0? So 4 times 7 to the 0 power. I know this will be the starting value, but let's see, 4 times 7 to the 0 power. It gives us the answer of 4. Next up is number 3. What is the initial starting value of the table? So what number would start off? So there is a trick to find your multiplier. Your multiplier is you divide 250 by 1,000, or the number divided by the previous, or into the previous. That gives us the multiplier is, what is 250 divided by 1,000?
I found this on the web.
250 divided by 1,000.
The answer is 0.25.
0.25. So that means the multiplier is 0.25. Now, if I work backwards and divide by 0.25, 1,000 divided by 0.25.
The answer is 4,000.
We'll get our answer of 4,000. Now double check, does this number seem appropriate? 4,000 to 1,000 to 250 to 62.5. You can also decide that this is something like dividing by 4. Dividing by 4 is the same as multiplying by 1/4. So that number is correct. Number 4, which equation matches the image? So the main thing is that we have the starting value right there. It says the starting value is 24. So it needs to be y equals 24 times something to the power of x. Now, how do you get from 24 to 12 and from 12 to 6 and 6 to 3? That's the multiplier. 24 times a half, 12 times a half, and 6 times a half is going to be our answer for the multiplier. So this is the equation. Now, which one matches this equation? The correct answer would be letter E. Because this can also be written as y equals 24 times 0.5 to the power of x. So that was correct. Letter E was the answer. Okay, next up is problem number 5. Problem number 5 says, what is the multiplier for the following table? What is the starting value for the table? And also, we should be figuring out the equation of this as well. So the multiplier, I can see, is times 3, which you can also figure out by doing 99 divided by 33, or 297 divided by 99. Let's confirm. 99 divided by 33.
That would be 3.
So their multiplier is 3. If I work backwards and divide by 3, I will get my starting value of 11. So the starting value is 11, the multiplier is 3, and therefore the equation is 11 times 3 to the power of x. Now finally, number 6, write the equation that matches the table. Here's our starting value. What's the multiplier? Multiplier is going to be times 5. And that's the answer. Again, use the trick where you divide the two numbers here. 20 divided by 4, you'll get 5. If you do 100 divided by 20, you'll get 5. If you do 500 divided by 100, you'll get 5. So there's many ways to get this answer. So that covers standard, we've already covered standard 6C, 7B, 7C, and 8A.